After parsing the SQL query and performing the checks in the preprocessor, we convert the parse tree to an initial logical query plan, which is in form of an array tree, meaning relational algebraic representation of the tree. In the next couple of slides, we are going to discuss this step, which is also called convert step. Just a quick note here, again, that these steps are representative and might be different in different relational database management systems. So, for example, instead of the array tree, an annotated version of the parse tree could be passed from the parser to the optimizer. During this step, the array tree will be built in the converter from the bottom to top from the parse tree. And the resulting array tree, which is processed expression of the query, will be passed as the output of the parser and to the optimizer. The optimizer then will use this initial logical query plan, apply some algebraic laws for improving it, rewrite it if needed, generate the plan, and perform steps such as enumeration and cost optimization. A SQL query, after being parsed, will go through a number of steps to generate the logical query plan. For example, conversion to relational algebraic representation, as we discussed. Removing subqueries from conditions also happen as one of the steps in conversion to the array tree. After these two steps, we have converted the parse tree to an initial query plan represented by an array tree. Improving the logical query plan by applying the laws, array laws, can happen after. And grouping associative and commutative operators if applicable. Here, we first explain the first two steps completely, as we need them in converting our parse tree to array tree. Then we provide basics for applying steps 3 and 4, which happens in the optimizer. Before we start converting our parse tree to initial query plan, let's review some array notation that we will use along the way. Cross, or X, is used to represent the cross product of two relations. Sigma, with underlined C, shows a selection with condition C. Pi, with underlined L, shows projection of attributes listed as L. Join, with condition C, shows the theta join of the tables with condition C. If there is no condition listed, we assume a natural join. Delta is used to depict duplicate elimination. Gamma is used to depict grouping. And rho is used to depict rename. Let's start discussing the convert step. After ensuring of relation uses, locating the relations and attributes, and type checking on the parse tree using the preprocessor, we now replace the entire construct, the select list, from list, and condition to come up with a construct which is an array expression that describes our query plan. In the simplest form, we replace the parse tree of a query with a condition with an array expression tree from bottom to top using 3 main steps. First, we replace the product of all of the relations mentioned in the from list at the bottom of the tree. This provides the arguments to the next level. Then, the next level of the tree is a selection with condition C, where C is the condition expression in the construct being replaced. Then, at the next level of the tree, taking that as input, we have a projection on list L, where L is the list of attributes in the select list. Using these 3 simple steps, we have our array tree.